Today, we are going to be talking about the next 3 ways you can prove congruent triangles. You've learned the first 2 ways, now you get the last 3 ways. Okay, so angle, sine, angle is the next one. Blake, focus please. Thank you. So what is the first pair of congruent angles in this? Angle what?
Angle A and angle B.
Angle A is congruent to angle D, okay. What's the congruent side?
AB and D.
AB and what?
D.
Good. And then what?
Angle B, angle E.
Angle B is congruent to angle E. Good. Now, if you notice, the side, it's in between our angles, correct?
Yeah.
That's why it's called an included side. That means it's in between your 2 angles. So if you're trying to tell me you have these 2 angles and then, oh, it's side DF. No. It's got to be the side in between the angles. Do we understand?
Yes.
Any questions? Okay. So what if I say triangle, let's be different here. Triangle CAB would be congruent to what?
FDE.
FDE, good. So make sure we have that. Alright, any questions about that so far? Okay, now we get to do the actual proofs. Yay! The first thing you write in every proof are the givens. How many givens are there? 1. Oh, it's in step 1, isn't it? Wow, that's not that bad. Let's see, step 1 says that SQ, what's this word?
Bisect.
What are we bisecting?
RQT. And
Which is a what?
URAQT.
These are what?
Bro. Great.
No, what are these?
Angles.
These are angles. We're bisecting angles. So what should probably be your reason?
Angle bisector.
Definition of angle bisector, but yes. I know, not everybody did though.
Oh, I'm sorry. I take that back. It's okay. It's okay.
Wait, what's that?
So definition of angle bisector, so that's going to be step 2, right? Because it said RQT, and that's that guy. So that would make what? RQS, that's this angle, and TQS, that's this angle, right? Okay, what else? How do I get step 3?
Okay, step 3, so it's RSQ. So let's look at this RSQ. So you're going the other way.
Oh wait, I said the wrong angles. Wow.
Yes, I was like, dang.
I did RQS and TQS. That's that one.
That's how I did
Okay,
it.
so these are the second ones that they're saying. How do I get that one?
You go like that.
No. They don't say parallel lines anymore.
Just definition of angle bisector.
Definition of angle bisector is the same thing.
Because it also goes down the middle right there.
Well, it was also in your given.
It
said RST.
You're right, Miss Howell.
So,
Wait, those 2 lines, that means it's the bisector, right?
Wait, how
No,
is
that
it
just
angle
means it's the
No,
same
no.
answer. It's the same thing.
that just means that this angle is congruent to this angle.
Yeah.
Wait.
That's what that means.
Oh!
Okay?
They're both
But how is number 3? Sorry.
Because it says RST, it's bisecting 2 angles. So we used it twice. That's how we got that.
Oh.
Now, step 4 says that QS is congruent to QS. How?
Reflexive.
Reflexive. See, I told you that would be your new favorite.
I do like reflexive.
Right? Alright, so,
ASA.
did you prove 2 angles with the side in between?
I'm okay.
Yes, so we can say it's angle, side, angle.
Oh, this helps.
Yay!
My friend who's in geometry, I asked him if he was doing like proofs. He said he doesn't even know what that is.
Well, I'm scared for him. Okay, number 2. Molly, chill. Alright, first thing you write in every proof are the,
Given.
where are they at?
1.
1.
No dying.
Wait, no, there's 2 givens.
Yeah, they shoved them both in.
Yep, there's 2 givens. Alright, so what do these liney thingies mean in your given?
The parallel.
Okay. So JK is parallel to LM, and JL is parallel to KM. What did Miss Howell tell you to look for anytime they tell
Angle
you?
relationships.
Wow. Okay, next time wait till I just finish saying it. Although I appreciate the enthusiasm. Okay, now.
That was all you meant.
So, what could we find from JK and LM?
Hey, just kidding.
Alternate interiors, Mikey. Which one? Oh,
What?
never mind.
That's what I was gonna say.
Alternate interiors.
Wait, where were we getting alternate here?
They said the lines were parallel. If lines are parallel, you can do angle relationships. So that's JKL, so that's this guy, and then MLK, which is this guy. So those are alternate interior, correct? Yeah.
Yeah.
So you're gonna put alternate interior angles. Alright, now how do I get the next one? How do we know that JLK, this guy, is congruent to MKL, this guy?
I don't know, maybe alternate interior again.
It's alternate interior again! Because this was another group of parallel lines, so they were using the second set that they said. Okay. And then how do we get KL is congruent to LK? Reflexive.
Let me guess. ASA.
I'm gonna guess it's SSS.
Yep.
I think so.
And I swear, if any of y'all put reflective on your papers, I'm gonna judge you a little bit.
Wait, do what on your papers?
If you put reflective instead of reflexive,
Why is
Oh,
it
I may have done that
Why
one.
did you
Homework,
because,
that's fine.
yeah, no. I'm gonna judge you a
Yeah,
little
I
bit.
just said that.
Because it's KL and OK.
Can I see your shirt?
Because, shh, listen please. Blake, no. Okay, Mikey asked a good question. Why doesn't it say KL and KL? The reason why, you see how KL, how it goes from the first angle to the second angle? LK does the first angle to the second angle. You have to go in the correct order, okay? Same thing as the proof statement. It goes JKL and then it goes MLK. It goes down and then up right. And then it goes up and down left. There, you're going opposite directions.
Oh.
So you have to name it in opposite directions. Okay?
That makes sense.
No, that's not what that means. It just means you didn't know, but now you do.
Well, I wrote some metric on my homework.
Well, don't do that. Alright, take paper, turn over. Because we have more. Oh no, they didn't write anything for you. Aww. You gotta do it all yourself. So the first thing we write in every proof are the givens. You can write them separately. You should be writing.
I wrote my angle sign so good.
Good job.
What, Mikey?
I don't know why this one marker is so loud when it writes. And all the rest.
I wonder.
Alright, your first given says that BAC is congruent to DEC. That's those two angles, correct? Alright, what does the second given say?
Midpoint.
Uh-huh. So you should probably use what?
Definition of midpoint.
Okay, but what would be our statement though?
AC is equal to EC.
Good, Noah. AC is congruent to EC.
Good job, Noah. Noah's in that?
It'd be nice. I feel like I have the heat going.
I have the heat going.
Molly, later, never now. Thank you. Alright, now, so we have one set of angle and one set of sides. What are we missing? Another angle. Good. What angles could we use?
BCC.
Those are sides, not angles.
I know. No. I know angle. Oh, what the heck? Maybe C.
B, C, A, and what?
E.
You went the wrong way.
A, B, C, A.
So
Then C, D, E.
if you're gonna do BCA, it should be DCE because you're in opposite again. Okay. And what types of angles are those?
Vertical.
Good. That should be another like favorite types of angles that you use.
Wait, DCA and what?
DCE.
That's like the
These
first
guys.
time I actually got one of the things right.
Yay. Progress.
Practice makes perfect.
They're just like really hard.
It can be slightly confusing. But again, remember when you take your test for these, it'll all be multiple choice, drag and drop, or it'll be in a box. So it's not like you have to think of this by yourself. All right, now, did we prove 2 sets of angles with the side in between?
Correct.
Okay, so we can say our triangles are congruent then.
Alright, so this is one of the closest ones.
Molly, can you put your foot down? Thanks.
Matthew, every time you say correct, in my head I say Matthew say correct.
Okay then.
This is the closest one we're gonna get to the
Yes.
Good job.
All right, the next one is angle, angle, side. And again, as previously stated, in case you forgot, no, ASS does not exist. Don't ask. Don't put it on your paper.
But angle side, that would probably be it, right?
No, that's
No, it don't exist.
No, like if it existed, it would probably be like angle
You
side.
have side, angle, side, angle, angle, side. That's it. Angle, side, side does not exist.
But
Don't
would that
put it on
make
your paper.
sense?
Angle side doesn't
No.
make sense.
No, it's basically the same as side angle.
What's SSA?
No, no, no.
SSA?
No.
Nope. There's side, side, side.
So there's only 4.
No, there's 5. There's one more on the back of the next paper.
Oh.
All right, now the difference between angle, side, angle, and angle, angle, side is where the side is. This time it's a non-included side, which means your side is after your angles. Okay, do we see that? It comes after the angles. It's not in between them this time, it's after it.
It feels like
Okay, so what's our first group of congruent angles? Angle A, number 1, is congruent to angle D. What's our second set of congruent angles?
Angle B is congruent to angle B.
Angle B is congruent to angle E. And then our side.
Side BC is congruent to side EF.
BC is congruent to EF.
so smart.
Okay, and if I wrote triangle, let's see. What if I did CAB?
FDE.
Good. Okay. Alright, questions about this so far? Yes, no? Maybe? Possibly?
I believe in you.
Okay, let's do a proof. Oh no, they didn't write anything. Aww.
Can I cry?
So the first thing you write in every proof are the.
Given.
Yay. How many are there?
2.
Oh, you can write them separately. You're welcome.
Yay.
Blake, right?
He's distracted.
I feel like both of you distract each other equally.
Wait, look. I turned like the N and give it into like the pointy, like the arrow. That's so hard. You skip.
Wait, can I see?
Good job.
Ah.
Probably know it.
Smarter, not harder.
Smart enough. Aw.
Work harder, not smarter.
What about coyote?
Ensign. She's eating the
Wait,
pole.
can I show you my cool trick?
What's it taste like?
Record.
Can I show you my culture?
Alright. Wow.
What?
So the first given says what?
YZ bisects WYX.
And what is this thingy?
Bisect. Oh, angle.
This.
Oh, angle.
Oh, we're bisecting an angle. So what do you think step 3 should be?
Bisecting angle. Or angle bisect.
Probably a good idea. Definition of angle Bisector. All right, what angles am I gonna write though? Well, we're bisecting WYX. That's this guy up here, right?
So it's WYZ and XYZ.
Correct.
I'm a smart girl.
She's not wrong.
No.
Okay. Blake, right? You're behind. Alright, so we have we used the first given. The second given said YWZ, so that's this angle. And then YXZ, that's this angle, right? So what are we missing now? We're missing a line, a side. What side could you prove? No. YZ, because reflexive. Now, am I gonna say YZ is congruent to YZ?
No.
YZ congruent to Y.
YZ is congruent to ZY.
Hang on. Are these the same angles here? Then you can go YZ, YZ.
Yeah, that's what I thought.
You don't have to flip it. If you want it wrong. Like if you did ZY, ZY, that's fine. Liam, you okay? You sure?
Is there like, do you have to keep it like that or can you fix it?
If you did ZY, ZY, that's fine.
Well, I'm saying.
If you did YZ and ZY, no, that would be wrong technically.
Okay.
Alright. So did we prove two angles with the side after it? Yes. So now you can say triangle WYX is congruent to triangle XYZ because of angle, side. Huh?
WYZ.
Aw, sad face. I messed it up.
Did you make the same mistake as the last class?
No, I did not actually. Yeah, there you go. Never happened. Ah,
Hey, what does your shirt say?
I want a hippopotamus for Christmas.
Did you ask
Why
Mr. Halford?
not? Huh? I did actually. Actually, this is why I have two inflatable hippos in my front yard.
Oh, is that what he gave you instead?
Huh? Yeah. Yesterday he let me get a gnome, so now I have a gnome in my front yard.
Oh no!
He's got like a big Christmas tree hat. He's like this tall. I haven't named him yet.
That's like as tall as Emily.
Hey,
I think you should
nice.
name him Willow.
No.
Why not?
No. No. Alright, number 5.
No, it's a
Later.
Christmas present.
Number 5. The first thing you write in every proof are the Noah. First thing you write in every proof are the
Given.
Alright, there are how many givens?
3.
3. Make sure you're writing 3 givens, please. Liam, find the paper. Yeah. I'm sorry. I still need you to write this though.
Do they go in different ones?
Yep, you can put them in different. Hey, but at least that's like half the proof.
I really thought it was dead.
Let me get you this out. We're gonna have to use angles. Stop, like, relationships.
I swear, someone keeps whispering.
Alright. The first given, they told you ABC is congruent to CED, right?
Alright.
So we got some angles. What does the second given say?
AB is parallel to CE.
Oh, we have parallel things. What do you look for when you know things are parallel?
Angle relationship.
Okay. What angles could we find?
Congruence. Corresponding.
Alternate.
What corresponding ones?
B and E.
We already found those. That was the first given.
A.
Side angle side.
And
Oh, A and D.
Not A and D. A and C. Okay. Specifically, Liam, Graham. Or Noah and Graham, sorry. Okay. Specifically, I want this angle A and then I want this angle C, right? How would I write that?
And corresponds.
Oh.
Well, yeah, corresponding. I mean the angle names.
Angle A.
So here, start at the top. So go BAC and then there you go.
Wait, how is it correspond?
Hmm? Yes.
Maybe is he wrong?
Okay. Alright, and then Mikey's been dying for this next part. Mikey, what are we gonna do next? No. What's the next part, Mikey?
Definition midpoint.
Definition of midpoint. Woo, go Mikey.
I just had to go into the back of my head and figure it out.
Oh yeah, definitely. I'm gonna just say it behind you. It's cheating.
I mean, he's been saying this since the first given, so. Okay. So we're using that third given for this one. And it says it's the midpoint of AD. So what should we write for our statement? AC is congruent to what? No, CD. Because A is congruent to C, correct? So you want AC and then CD. Because you have to list the ones that are congruent with each other. So you're going here to here. Does that make sense,
Wait,
Shaden?
I don't get it. Wait, why do you
What would it mean when it's the opposite?
Then if you went this way, you're telling me that A is the same as D. Is A the same as D? No. A is the same as C, which is why we put it that way.
Oh, that makes sense.
Because you have to go in the same direction. Alright, so did we prove 2 angles and then a side after it?
Yeah.
Yes. So we can put triangle ABC is congruent to triangle CED because of angle phi.
He actually doesn't put A as
Huh? No, I didn't. Yes. Not right now. No, we're not doing Pokemon right now. Alright, number 6. The first thing you write in every proof are the givens. So I need 2 givens here. Come on, Addison. What? No. No, I said Addison. Oh. Right.
That's my sister's friend's mom's name.
That's my sister's aunt's friend's grandma's daughter's name.
I'm not even lying. My sister's friend's
No,
mom's name.
nope. The first given was the after notes. Thank you. We just have I think like 3 proofs left, and then you can do whatever.
What?
Okay, I want 3 proofs. Okay,
Yeah, but then you got homework.
you'll be fine. Okay. Let's see. The first given says PR. What?
Bicep.
What are we bisecting? What's this?
An angle.
So what should we probably put for step 3?
Definition of angle bisector.
Yay.
Next, stop.
Whoa.
Hey. Now, what do we what did we bisect?
R.
So that would make what congruent angles?
S R and Q.
Those are sides, not angles, Matthew.
Sorry, angle R.
You can't say R. There's 2 R's.
P R Q.
PRQ and
PRS.
P. Nope. If you're gonna do PRQ, you have to do PRS. They're going down. Okay. So you can say angle PRQ is congruent to angle PRS. Alright, so we use that first given. Now the second given. Oh, they're so nice. They told us that PSR, so they told us in the second given that this guy, they told you this guy equals that guy in the second given. That's so nice of them. So what are we missing if we want to use angle, side?
Side.
A side. What side could you prove?
PR.
PR because of what?
Reflective.
Yay. So PR is congruent to what?
PR.
Good. Because these triangles are following the same direction, so you can say PR, PR.
I know that one.
Good. Reflexive. If you put reflective in your homework, I'm going to judge you a little bit.
No, don't
And
judge.
possibly mark it wrong.
No, don't judge.
We listen and we don't judge.
Too late.
Yeah, we listen, we don't judge.
Y'all do that anyway.
Stop looking at me like. Name one time we judged me.
Judging is bad. though.
Yeah.
I understand that, but I can guarantee you most of you have done that.
I've been done for my mom.
Okay? Alright, now,
People whose jobs is to be judged.
that's different. That's a different type of judging. Okay? Alright.
Like, making a verdict.
Girl power.
Molly, JC, Mikey, and Liam.
Yeah.
Alright, number 7. Like I said, 3 more proofs. Then we're done. Then you can talk. Okay? Alright, no. Well, I mean, you can, but it'd be like a 2-minute nap. First thing you write in every proof are the. How many are there?
2.
Alright, write both. Noah, write both.
You know LG is the brand of my TV.
Life's good, that's what it means.
It stands for life's good. Oh yeah, good job. Patrick.
What about good life?
Okay.
Oh, he said hello, so
Alright. Our first given. What do these liney things mean?
Parallel.
parallel.
Parallel. What do we look for if things are parallel?
Angle relationships.
So I need LG and JM. What could we find? JC.
Alternate LH, G, and J.
That's not from parallel lines.
Oh wait, I have one.
Ben.
Oh. I'm gonna ask about these.
Sure. Liam?
Take my shoe.
Yes. Which ones are alternate interiors?
L, H, H, M, J.
Okay. Okay. I have a question. Could we also use like G and J?
Yeah.
Yeah. Okay. They're both parallel. Because the lines are parallel, you can use L and M or you can use G and J. It's up to you. Okay. Liam said L and M, so we're gonna go with L and M. Because we're parallel lines. Because they're parallel, you can use alternate interior. And Miss Howell's gonna be more specific in her names, so I'm gonna say like GLH is congruent to, what would it be? GLH, so JMH? I feel like.
J and H, right?
Ugh, no, I has. Thank you. Okay. There's another one. Alright, so we just proved that guy and that guy. What else? Because if we want angle side, we're kind of missing some things. Triton.
Definition of this.
Okay. What's our definition of midpoint? Backwards. Better. So he's saying LH and MH.
Wait, I don't get it then because last time I thought you said it had to be like LHHM.
Okay. What angle is L congruent to?
N.
So if L is congruent to N, then you start the first one with L and the second one with M because they're congruent with each other. Make more sense?
Wait, so what would make it that it had to be H first?
If H was congruent to
If
L,
you could do HL and HN. It's honestly just however you wrote it. You'll be fine.
think positive thoughts.
Hey, Matthew.
I think the next one's vertical. Vertical angle.
Alright, Matthew said we should use vertical angles. So I want everybody to look. What angles are the vertical angles?
Probably LHG and JHM.
So it's the H's, right? So if we use the H's, okay, would this still be angle side?
No.
Ah, okay. So Matthew, you're not wrong. If I was asking you to use anything to prove the triangles are congruent, you could do that. But because I want us to practice angle side, I don't want you to use H. So what's the other set of angles we need to prove? Blake.
G, J.
Thank you, Blake. Your voice changed. You should get that looked at.
Oh,
What is it?
no.
It should be more alternate interiors, right? That's for all of you, right? Okay. So LGH and correct. So we're gonna use those guys. So let's see. Angle L, G, H is congruent to angle. Come on, you let Ben in. Thank you, Emery. All right, now can we prove that using angle side? Yeah? Okay. Now, was this the only method to prove that? No. Fun fact, Mod 3 solved this a completely different way. So for Mod 3, what they did is they used these and then the vertical and then this. So they went this way, where you guys went that way. Okay. So they used they just didn't use L and M. They didn't use those. They used the vertical angles in the middle. And that's how they did that one. Okay? So again, there's different ways to prove it. You could even do what Matthew did and do the angle side angle. Which is not what this question was asking for. But again, it would still work.
Wait, can you keep it different this time?
No. I'll put it up there at the end. Because I want us to get through this. We only have like 15 minutes. And I need to get through HL. But I will put it up there when we are done. Okay? Alright. Hypotenuse leg theorem. Okay? Fun fact. Hypotenuse leg theorem can only be used with right
Oh, so
triangles.
if you see a right triangle and it's like, what do you use to solve this? You
Yep,
just
it's
automatically
hypotenuse leg theorem.
I didn't remember that.
Okay?
Remember HL.
Right.
Again, remember this is going to be a multiple choice question, Piper. Okay? This will be a multiple choice question, so you don't have to really remember it, just recognize it. So in somewhere in the recesses of your brain, you should be fine. Now, here's my question. For hypotenuse leg theorem, Blake, turn paper over. For hypotenuse leg theorem, which part's the hypotenuse?
I don't know. A and B, I'm guessing.
Nope.
B
Try
and
it.
C.
B, C, and D.
BC and what?
Yeah.
Correct. It's the sides across from your right angle.
Oh, that's
That's how you know it's your hypotenuse. The hypotenuse is always the longest side, and it's also the slanty side. Because you see how the other two, how they make like an L shape to make your right angle? But this one's slanty. Okay, your slanty side is your hypotenuse, the one across from your right angle. Now, these other two, these are called legs. So this is one leg and this is another leg. For a hypotenuse leg, does it matter which leg you use?
No.
No, it's just whichever leg you can prove, that's the one you should use. Okay? So in the picture, they picked the leg for you. Okay? But first, what's the hypotenuse again?
BC is congruent to E.
BC is congruent to E, F, and then what's our leg?
AB is congruent to
AB is congruent to DE. Okay. No, AB, DE for the leg. So then, if I said triangle ABC is congruent to what?
DEF.
Yay! Good job. Alright, so let's try a proof. See what we can do. There's only 2 of them. Shouldn't be that bad. Alright. So, the first thing you write in every proof are the givens. Let's see. How many givens do we have?
2.
Where are they at?
1 and 2.
1 and 2. Now, big secret here. What was the first given?
L, M, P, and M, N, P.
Wow. This is going to be the first statement you should see in a hypotenuse leg proof. If it doesn't say something about right angles, 90-degree angles, something like that, you probably aren't going to use hypotenuse leg. Okay? It has to state that triangles are right before you can use HL theorem.
Are we probably not going to, or we're just not going to in general?
What?
Is there like a, because you said we're probably not going to be using hypotenuse legs. Is there a chance where we could?
If it doesn't say, if there is nothing in any of this about a right angle, 90 degrees, like congruent angles are 90 degrees or right triangles, you're probably not using it. Like that's a 98% chance probability that's not going to happen. Okay? So if it says right triangles, 90 degrees, right angles, you should probably use hypotenuse leg. Alright, the first given said that ML is congruent to MN. Is that the hypotenuse or the leg?
Hypotenuse.
Hypotenuse. I'm gonna make you practice saying that. Hypotenuse. Oh, Matthew. I love you, but you drive me crazy sometimes. Alright, all of you are special in your own ways. Alright, now the next one. They said MP is congruent to MP. It is what? Reflexive. And is that the hypotenuse or the leg?
Leg.
Leg. Again, does it matter which leg?
I don't think so.
No. As long as it's a leg of the right triangles, and it should be the matching legs. Let me say that. If it's not the matching leg on the triangle, so like you can't do the longer leg and then the shorter leg. It don't work. Has to be the same matching one. Good, stop. Alright. So put your hands to yourself. Thank you.
Wait, number 4 would be HL.
It would be HL theorem. Yes.
Theorem.
Yes, this one's a theorem.
Oh, so we're
Ew.
gonna fancy stuff.
I like this one the most.
Okay. Yeah, THM. If you want to abbreviate it, use THM for theorem. Okay, now number 2. Oh, it's a blank proof. You gotta write it yourselves. How many givens are there?
3.
Okay, that's over half your proof. You're welcome.
Thank you. Good job, guys.
We love
What
this
in the
out.
world was that?
Nobody knows.
And we think math is a little bit special.
Okay, now when you're writing that they are right triangles, the word triangles at the end, you can just put the symbol for triangles, and that'll work. You should be able to fit it now.
No. I didn't.
Well, then you write too big.
Wait, so is the fourth one just definition of midpoint?
Maybe.
Yeah.
Yeah.
Well, I don't want to spoil it.
Wait, so is it
Or was it not?
WV? Are these two different givens?
Hmm?
Yeah.
Yes, you should have separated your givens. My papers keep falling. Okay. Alright, so your first given said that the triangles are right triangles, which is what we need. So now let this like a check. Yay, now we can use HL. And then they said that WV is congruent to YZ, right?
Yeah.
Says those things. Question, is that the leg or the hypotenuse?
Leg.
The leg.
That was the leg.
So now,
So now we need the hypotenuse. So your next given says that x is the what? What do you think should probably use?
Definition of midpoint.
Wow, craziness.
I know.
So definition midpoint, and what am I going to write for my congruent statement, though? Wx is congruent to what?
Why?
Okay, I like it.
Wait, what happened?
So Wx is congruent to Yx. All right, is that the hypotenuse?
Correct, yes.
Yay! All right, so can you use hypotenuse leg?
Yeah.
Yay! All right. Daniel, can you answer the phone? Why was I writing that?
I got on my board.
Okay, hang on. Alright, so you have finished your proofs. Now you have your homework. Or if you need to put your binder together for Miss Howell to check it, now would probably be a great time.